All right, so we got the next lab. It's on river erosion. I know 3 labs 1 week, but the porosity one was really, really, really fast. This one has a couple pages to it, so definitely that's one of the reasons why I've been giving until Sunday to get the labs done. They need to get handed in. You need 1,200 lab minutes to take the regents. And so far, if you've done all of them, you should be up to 300 minutes right now, which is great. It's a great start because we have until January 29th, actually less than January 29th, probably like January 20th, to get all these lab minutes in. Okay, so on to the lab. River erosion, type in anything that has the orange. Again, and to get to the gizmo, you can click right here, which is pretty cool. And you've got your prior knowledge questions. Do these before the gizmo. So the image above shows a raging mountain river in full flood. What do you think is making the water brown in color? What impact do you think flooding will have on the surrounding landscapes? Answer those, please. Okay, so warm up. If you stand by the bank of a river, it may seem that very little is happening, but over thousands and even millions of years, rivers have profound effect on the landscape. In the River's Erosion Gizmo, you will see how rivers move materials and how they affect landscapes. So to begin, check that the mountain stream and short-term erosion are selected. So you're going to get to here, mountain stream, short-term erosion, they are clicked on. Okay, the 2 movie cameras allow you to observe different parts of the stream. Click on the left camera and what do you see? Left camera is this one. Right camera is this one. Let me know what you see. Write it down. So the left one, you write what do you see in the left one? Sediments are small fragments such as sand pebbles. Whatever evidence do you see that sediments are being transported? What do you see in that little video? Now select the right camera to see the bank of the mountain stream. What's happening to the sediments in the bank? All right, click on the mountain stream and short term, which it is already at. We're going to look at erosion and weathering. So first things first, get to know some of the different parts of the mountain stream. Turn on show labels and label the image to the right and fill in the word that goes with the description. And I'm going to highlight this because a lot of you aren't doing this, and I'll show you how easy it is to do. So when you go to this, show labels. So we've got lots of labels shown right there. And what you're going to do on this is you're just going to do this. Double click and then double click again for each of these. And you're going to label all of them. Save and close. It's there. It's labeled. Okay, and then you're going to answer these following questions. A small stream that flows into a larger stream. What is that? Use the terms. You have the terms right here. Use them to fit in. The side of a stream, the bottom of a stream. Well, a letter that describes the shape of a typical mountain valley. A place where the stream water drops straight down. Okay. So observe. Turn off show labels next to release barrel. Click play. So I'm going to hit play. I'm going to pause it right now. The 2 flags are 100 meters apart. Oh, sorry. Observe how fast the barrel moves as it floats down the stream. What happens to the barrel as it goes over the waterfall? So where's my barrel? My barrel's up here. You're going to play it until it goes over that, and you're going to write down what you observe right here. Then you're going to calculate. The 2 red flags are 100 meters apart. The time at which the barrel passes the flag is shown. Remember, there are 60 seconds in a minute. How many seconds did it take for the barrel to go 100 meters? So, river, play. So I'm just letting it play. And I'm going to stop right there. So I have two different times. You are going to subtract the times from each other. Remember, time is in 60 minutes, not 100. So that'd be 440 minus 309. That'll work out because it's not over 40. All right, so to find the barrel speed, use the calculator to divide the distance between the travel time, 100 milliliters, or 100 meters, by the time it took the barrel to float that 100 meters. The units are meters per second. So 100 over this. That's what you're going to get right there. That's the speed of the barrel. Click reset and turn on show data. So click reset, show data. The slope of the channel is how steep it is. How many meters the stream bed drops for every horizontal kilometer. What's the slope of the stream? What's the river speed? Because it gives you river speed. So, wrong thing. So channel slope, river speed, river discharge, sediments transported. So you're able to answer these questions based off of that. Observe, turn on off show data next to river flow, select flood. So show, I'm going to do flood. Woo, look at that. All right. Look at the landscape and click on the movie cameras to see the zoomed in view. Describe what you notice below. For both, there's two of them. So I should have two different sentences. Calculate. Click the play release the barrel. How many seconds does it take for it to get from one flag to the other? There's that time. And the speed. Remember, time over, or 100 over time. Compare. Turn the show data and during the flood. How do the river speed, discharge, and transported sediments compare to the flow condition? So you'll turn on this again, get the data. All right, so select meandering river, click short-term erosion, low vegetation. So let's go meandering river, normal. I want low vegetation, normal. See, short-term, long-term, low vegetation and normal. Turn off show data. I think I did that already. Yep. All right, meandering streams are found on flatter areas. Valleys of meandering rivers have wide, flat bottoms called floodplains. So you're gonna, oh gosh, yeah. Huh. You are going to label this by double clicking, and you can label by clicking show labels. So you're gonna label these on here. And remember, all you have to do is double click. Once you're done, save and close. A large S-shaped bend in the river. Well, let's see. All right. Large S-shaped bend. It's like the cup bank. You would write that down. The flat area next to the river. So you're going to use those 4 vocab words right here. And you're going to fill in based on where they are. Okay. Turn off show labels. Click play. Do the barrel again. So show labels, click play, and you got the barrel. How many seconds did it take for the barrel to go 100 meters? Remember, there are 60 seconds in a minute when you go to calculate. What is the speed of the barrel? Remember, it's 100 over this. Turn on show path. Did the barrel stay in the center of the river or go from side to side? So where's the show path? So once you have play, it's going to follow the path. And just answer the question. As the barrel went around each meander, did it stay closer to the point bars or the cut banks? In a meandering river, the water flows faster on the outside of the meander, just like I said, near the cutback. So current carries the barrel towards the cut banks and away from the point bars. Compare, you're going to compare, click reset, turn on show data, list the slope speed and discharge and transported sediments in the meandering river. So you go to this, you go to show data, and you're going to start copying stuff down, writing stuff down in here. In what ways is the meandering river different from the mountain stream? Compare the two different amounts of data. Observe, turn off show data, click the right movie camera and see the cut bank. Look at the sediments above the water. What do you see? So you're going to look at here, or sorry, here, and then there, okay? Compare, click the simulated area to turn off the movie cameras, select flood, right here. The flat area surrounding the river is called the floodplain. Why do you think that? Why might it be a bad idea to build a house in the floodplain? Turn on show data. How do the flood conditions differ from the normal conditions? And look up the two close views. What do you notice? So you're going to turn this on. You have your labels. You're going to click on these two and fill out. All right, so we're going back to mountain stream, long-term erosion, and low vegetation. So I'm going to do long-term meandering, low vegetation. All right, this is going to be a predict. How do you think the mountain valley will change over time? Click play and observe the valley for 200,000 simulated years. So you'll hit that for 2,000, okay? 200,000. Analyze, click reset, and turn on show data. So you're going to go like this. You're going to reset, show data. All right. Click on play, wait until the end of the simulation, and record the same data. So you're going to record right here first, and then you're going to record right there. What's the channel slope, river speed, discharge? You're going to do the same down here. How does the stream data change over time? What's the difference between these two? Click reset, and click the movie camera to see the views of the side of the valley. Click play. Over time, does the valley erode downward or side to side? Click reset again. Next, vegetation to high. Click play. Compare the end results of 200,000 years with the high vegetation to the low vegetation. Which landscape eroded more, and why do you think that is? I'm going to highlight it because you guys don't like to answer why. Predict. Click reset. Select meandering river, low vegetation. How do you think the meandering river valley will change over time? Click play, observe for 2,000 simulated years. What do you notice? Over time, do the meanders grow wider, narrower? Turn on show labels. What features are formed? Click reset. Turn on show data. Click play and observe the river data. So reset. Watch the river data. See what you got. Click the movie camera to see the side of the valley. What do you notice about the shape of the river channel? Click play. Does the channel erode downward or side to side? Finally, last but not least, click the next vegetation, select reset, next vegetation, select high, play, and then compare after 2,000 years of erosion with high vegetation to erosion and low vegetation. Which landscape eroded more? Why do you think? All right, guys. So this is your weathering or your erosion of your stream. If you have questions, email, Zoom, class tag. Hope you guys have a great day.